Hello students, in the problem set there are three examples which children may find confusing. So I am simplifying them and bringing it to your level, and I hope you will be able to solve it. Okay. So in problem set number 1, question 5 and 6 on page number 28. So this is the first example, question number 5, sub question number 5. You are given that these three ratios are equal. So if you equate first and second, if you use first equality and cross multiply, simplify, you get this equation. This is a very simple equation in x and y, linear equation in two variables. Now by equating second and third, you can get one more equation in x and y. Also by equating first and third, you can get one more equation. So you can get three equations in x and y. But we need only two. So I am equating first and the third. So I wrote first and third equated. 4 is cancelled by 2, cross multiplied and simplified. I am getting second equation in x and y. This is x minus y equal to minus 4. This is x minus 3y is equal to minus 16. I will solve these two and we can get the values of x and y. This is question number 6. Sub question number 3. 148 upon x plus 231 upon y equal to 527 upon xy. A similar equation, second equation is given. Okay. Now, what is confusing in this problem? You are given x and y in the denominator. So normally when x and y appear in the denominator, we say that 1 upon x should be considered as a, 1 upon y should be considered as b. But it is not so in this example. If I multiply both the equations by xy, because the denominator contains xy. So if I multiply the first equation by xy, here xy, x cancels with x, you will get 148y, 148y. Here also you have to multiply by xy, so y cancels with y, you will get 231x, and if you multiply the right hand side by xy, xy cancels with xy. So your new equation will be 148y plus 231x is equal to 527. 148y plus 231x is equal to 527. Similarly, if you multiply second equation by xy on both sides, every term must be multiplied by xy. Okay, so you get 231y plus 148x is equal to 610. What do we observe? The coefficients here are interchanging in the second equation. 148, 231, 231, 148. And we know how to solve these types of problems where the coefficients are interchanging. We have solved many such examples. This is question number 6, 4. It is given in this form. 7x minus 2y upon xy is equal to 5, and similar equation, second equation. Now, if I write xy under the first term, x and x will cancel, I get 7 by y. If I write xy under the second term, 2y upon xy, yy will cancel, you will get minus 2 by x is equal to 5. Similarly here, if I write xy under the first term, xx cancels, 8 by y plus 7 by x is equal to 15. Okay, now this is going in type number 1, where you have to consider 1 upon x as a, 1 upon y as b, or you can take 1 upon y as a and 1 upon x as b, and therefore these equations will then change into 7a minus 2b is equal to 5. This equation will change to this if you consider 1 by y as a and 1 upon x as b. And the second equation will change to 8a plus 7b is equal to 15. And then you can solve these equations, get the values of a and b, and from that you can get the values of x and y.